Dear students, in this video we will discuss about the ionic bonding. Ionic bonding is also one of the primary type of the bonding, and in ionic bonding there is the complete transfer of electron from one element to another element. So the ionic bonding is mostly found in elements which are composed of both metals and non-metals. As we know that metal can easily give up their electrons and non-metal can accept the electron. So in ionic bonding, four elements try to attain the stable electronic configuration. That is, for example, here we have the example of the sodium chloride. Like in the sodium atom, you can see that it has in first shell it has 2 electrons, so this shell is the complete, and the second shell sodium atom has 8 electrons, so second shell is also the complete shell, while there is 1 electron in the third electronic shell of the sodium atom. So here it has only 1 electron in its third shell, so sodium atom can easily attain the stable electronic configuration that is similar to argon, that is similar to the neon, by giving up its valence electron. So on the other hand, there is the chlorine. The chlorine has 2 electrons in its first shell and 7 electrons in its second shell. So sodium atom requires 1 electron to complete its inner shell configurations. So sodium atom will give up its electron and chlorine atom will accept the electron to complete its electronic configuration that is similar to argon. So in this way, sodium atom when give up its electron, it has the net positive charge and it's become cation, and that is the positively charged ion, while sodium atom by accepting this electron, now it has the net negative charge and it becomes chlorine negative ion, and it also called as anion. So the sodium chloride, here we can see that it's composed of positive and negatively charged ions, that is there are the chlorine and sodium. There is the alternate range of the sodium and the chlorine ions. So here we can say that that is ionic bonding is can be considered as non-directional. That is, the magnitude of the bond is equal in all directions around the ions. That is, there are as many anions as there are the cations. There are equal number of anions and cations to attain the stable to maintain its stability. So we can say that ionic bond is the non-directional. It follows that for ionic materials to be the stable, there should be all positive ions must have nearest neighbor as a negatively charged ions. So this is the schematic representation of the ionic compound. As we know that the bonding in the solids give the metallic specific properties to that material. As in the case of, we know that the ionic compounds are brittle. This is also due to the ionic type of the bonding. Whenever we apply the stress, that is whenever we try to hammer the material by applying the force on it, that is when we compress the materials, then so there will be the repulsion of the like ions, that is like charges in the crystal will repel each other, and due to this repulsion the crystal will get shattered. So that's why we say that due to the same repulsion of the same charges, it gives the property of the brittlity to the ionic compound. So the ionic materials are the brittle. So we can these can easily be fractured due to this property. In contrast to the metallic compounds, which are composed of which have the number of free electrons and can conduct the electricity, as the metals are the good conductor of electricity due to the availability of the free electrons. But in contrast to the metals, the ionic compounds, which are composed of sodium ions and the chlorine ions, and that is these oppositely charged ions are tightly bound to each other, so there is no free charge particle available for the conduction of electricity. So in the solid form, we can say that the ionic compounds are the non-conductors, that is, they cannot conduct electricity in a solid form. However, when we decompose the solid material into its ion, that is, when we make the aqueous solutions by dissolving the sodium, here we take an example of the sodium chloride. So when we make the aqueous solution of the sodium chloride, we decompose it into its ions, that is, sodium ion and chlorine ion. So the sodium are the positively charged particle, so we can say that these gather around the anodes, and chlorines, which are the negatively charged particles, and these are around the cathode. So when we apply connect the cathode and anode to the terminal of the battery, that is, when there is the potential difference, then the chlorine, which are the positively charged particles, they will move toward the anode, and the sodium, which are the positively charged particles or positively charged ion, they will move towards the cathode. So there are ions are the positively charged particles are available for the conduction of electricity. So they can now in the aqueous form they can conduct electricity. So we can say that the ionic compound in solid forms are the non-conductor of electricity, but when we make their aqueous solution in the aqueous forms, they are the good conductor of electricity. So in aqueous form, the charged ions are the charged particles are available for the conduction. Another important property of the ionic compound is their relatively high melting point. So this property is also the direct consequence of the ionic bonding. So as we know that the bonding energy, which is generally range between the 600 and the 1500 kilojoule per mole for the ionic compound, which is relatively very high, and that is because of this so much high bonding energy, these ionic materials have the high melting temperature. That is, here the bonding energy means that the energy which we require to break the bond. As we know that in the ionic compounds, the oppositely charged ions are tightly bound to each other, giving it the stable structure. So to break these bonds, we need very high amount of energy, that is between 600 and 1500 kilojoule per mole. So because of this much high energy, these ionic compounds have the very high melting point. Thanks for watching.